In this example, we are going to determine if quadrilateral WXYZ, keep in mind that a quadrilateral is a four-sided polygon, with its vertices at W, which has coordinates 1.5 and 6, X, which has coordinates 6.5 and 0, Y is at 5 and -4, and Z has coordinates 0, 2. We're going to determine if this quadrilateral is a parallelogram. Now keep in mind, a parallelogram is a quadrilateral, but it has each pair of its opposite sides are parallel to each other. So I'm going to go ahead and plot this. So I have a graph here, and you should too. It certainly creates a good visual and helps us it helps lend some clarity as far as what's going on. Now, keep in mind that what we're doing is we're using our understanding of slope and distance and area and things of that nature to help us determine the characteristics of these plotted polygons. So I'm going to go ahead and put in my axes here. Here's my y-axis, my vertical axes. And of course, here is our horizontal axes, our x-axis. So I'm going to plot each one of these vertices, each one of these points. W is at 1.5 and 6. 1.5 and 6. 1, 2, 3, 4, 5, 6. So this is W. Then X is at 6.5 and 0. 1, 2, 3, 4, 5, 6. And here's a half and 0. So it's right on the x-axis. Y is at 5 and -4. 1, 2, 3, 4, 5. 1, 2, 3, 4. And Z is at 0 and 2, so it's right on the y-axis. So certainly making a sketch, drawing it in, or plotting the parallelogram, certainly we can see what's going on. So we have this quadrilateral. Now, in order for it to be a parallelogram, both pairs of opposite sides must be parallel to each other. So in other words, the slope of this line segment here, this line segment WX, must have the same slope as this line segment here of ZY. Consequently, this line segment here, WZ, must have the same slope as this line segment here, XY. If those slopes, if the opposite sides are parallel to each other, they have those corresponding slopes, then of course, then this quadrilateral is indeed a parallelogram. So I'm just going to mark this one as X sub 1, Y sub 1, and this one is X sub 2, Y sub 2. So we'll find the slope of this one right here. And of course, we'll use the slope formula. M is equal to Y sub 2 minus Y sub 1 over X sub 2 minus X sub 1. And it doesn't matter which coordinates you label as X sub 1, Y sub 1. They're both going to yield the same slope. So M is equal to 6 minus 2 and then 1.5 minus 0. 6 minus 2, that's 4. 1.5 minus 0, that's 1.5. This is the same as 4 over 3 halves. And 4 over 3 halves, that's 8/3. You should always express your slopes in fractional form, at least for these exercises. So the slope of this line segment here is 8/3. So we'll now find it for this one here. I'll mark this one as x sub 1, y sub 1. And then this one x sub 2, y sub 2. So I'll find this slope here. -4 minus 0 then 5 minus 6.5 -4 minus 0, that's -4. 5 minus 6.5, that's -1.5. And again, you can see what's occurring here. That becomes 4 over 3 over 2. And that is also 8 over 3, 8/3. So the slope for this line segment, xy, is also 8/3. So this one has the same slope as this one. So if the line segment wx then has the same slope as the line segment zy, then this would indeed then be a parallelogram. So we'll go ahead and do that. We'll find this one first. So we'll take 6 minus 0 and then 1.5 minus 6.5 6 minus 0 is 6. 1.5 minus 6.5, that's -5. So it has a slope of -6/5 or 6 over 5. So that is the slope for this segment here. If this line segment here, zy or yz, has the same slope, then we know we have a parallelogram. So we'll do that. -4 minus 2 and 5 minus 0. -4 minus 2, that's -6. 5 minus 0, that's 5. So that's also -6 over 5. So both pairs of opposite sides are parallel to each other. So since they're both pairs of opposite sides are parallel to each other, this is indeed a parallelogram.